This should be running, and I just realized. Be right back. All right, back. Good. So yeah, we're on macOS 9 here, but actually writing a program for System 6. I've done a few things since the last stream, because this is kind of my my side project. So I guess I'll just quickly summarize. So what we're doing, just to recap, is we are writing a Macintosh application. I've written my own C++ application framework that uses the low-level API. That's necessary because on macOS you don't get a framework, so you have to do things like if there is a mouse click, then you have to, well, first you have a loop and you call wait next event to actually get the events that happen, you know, like mouse clicks, things like that, keyboard presses and all of those things. Then you have to check whatever event was it. This is all C API, by the way, so there are no objects, and some of the things they had to do to kind of make this stuff work are involve a lot of typecasting and other things. Then you call find window to find out, like, okay, where was this mount click? And then it will tell you, for example, oh, it was in the menu bar. Then you call a function that, you know, pops up the menu wherever you clicked and tells you which item was selected. They have like the content area of a window, then you handle that click in your window. The drag area of your window, then you call something that moves the window around. You know, like shows this gray outline wherever the window would go and then moves it to the right spot at the end. Same for the resize box in the corner, show the gray outline and then resize the window and like move all the window contents. Because System 7, even System 9 didn't have any, you know, like pinning or auto layout or flow layout or anything like that. It's just you create a control, you give it certain coordinates, and when your window is resized, you are responsible for moving everything so that it stays at the right edge of the window or whatever. The close box, you call a function that actually tracks mouse movement while the mouse is down and then tells you, and redraws the close box and then tells you whether the mouse was released inside or on the outside. And if it was released on the inside, it's your job to, you know, like decide, do I still need to save that document, and maybe show an alert saying, hey, that document hasn't been saved. Do you want to save, or do you want to quit without saving? All that stuff you have to do with for yourself. So in modern operating systems, of course, that's different, because in modern operating systems, all that is built basically, it comes with your operating system. Um, so yeah, and same for a lot of other events. For key down, I'm currently only handling modifier keys. Another thing, and so I wrote my own application framework. Another thing that you don't have, which is often very useful, is you do not have a console on macOS. macOS does not, classic macOS does not have a terminal. Modern macOS 10 and later, of course, has it because it is based on Unix, on a kind of BSD Unix. And so there isn't really, you start with a terminal first and then switch into graphics mode, but there, all the infrastructure already exists. The original Macintosh started into a graphical mode right away. And so if you wanted to log messages to the console, the famous printf debugging, you actually needed to create a window and draw the text into that window. Or in the case, if you had CodeWarrior, there is this library called SU. Standard Input Output User Exchange, I think is what the name stands for. It's, a backronym. They found a nice sounding word that kind of started with the right letters and then made the rest fit somehow. And that basically takes care of all of that. The problem with SU is SU is initially intended for when you have ANSI C code, and you want to just see that output and maybe input text, things like that. So by default, it assumes that it is in full control of the application, and it actually does all the Macintosh application specific startup and creates a bunch of menus and things like that. And so I added this library, but to use it, to print it here, I had to include a special header, the su.h header, which comes with CodeWarrior. And then here, I set SU up and tell it, so SU comes with a global variable where you can set some settings that is defined in this su.h header. And so I tell it, don't initialize the toolbox because my application already has done all this application-specific stuff. I tell it, you're not running standalone, you're running in my application, please be considerate. I tell it not to mess with the menu bar because I'm doing my menu bar. Auto close on quit. I think that was... I don't even remember. I think that might be wrong to set that false. But anyway, it's working for now. I thought it meant quit when the window is closed. That's why I set it to false. Ask to save on... Let's set that to true just to see, because like the name seems opposite from how I read it the first time. And I'm setting ask to save on close to false because usually you don't want to save whatever has been output to the console. It's just a bunch of debug messages. So I see that everything went right, or if something went wrong, I can check some values and check, okay, it crashed at this point. So now the problem is, of course, I'm processing events, and some of these events might be for the SU window. And so they have a function named SU handle one event that you call. And if it returns true, that means it handled the event. So you just say continue in your event loop, grab the next event. It's analogous to the way you handle events in dialogues, basically. But the problem, of course, is you need to do that so that SU knows what it is. Oddly, some events seem to go through. And so I had to litter a bunch of code with things like, okay, I found the window, and now if the window is the SU window, then exit here and don't do anything. Because apparently Sue sometimes doesn't get mouse down events. Like, I think that is like if the window is inactive, then certain mouse down events get ignored by Sue handle one events. So that's a workaround kind of, but it's now everywhere. And to do that, I actually had to do a little bit of a hack. There is this private Sue globals header that I found in the source code for Sue, and that declares this Sue text window. Where is it? Here, Sue text window global, and so I'm using that just to be able to. Oh, I just realized. I didn't start the bot, so nobody got a notification. That's not good. Well, anyway. So yeah. So I had to drag that header into my project so it would know where to find it. Because it's not a standard system header that everyone should have. So yeah, not quite easy, but managed to get it to work. So what that means is now if we start the application, we get this window here, this console window. You know, that works and that we can resize, and that shows a few messages while I use it, and I can use that for debugging. Of course, I can still bring up my windows, you know, next to it, so that's good. What else did I do? Yeah, we had one control class that was just a generic class, C++ class, to make it a little easier to create a new control and, you know, handle its behavior. So you can just say, poof, I want a push button in that window or something like that. For dialogues that works, but dialogues are very limited in what kind of objects may be inside a dialogue. Like if you see the resources file, oh, by the way, I added a quickly drawn icon. We have this dialogue resource, and you know, you have buttons, checkboxes, radio buttons. You can say control, but the problem with that is that will just perform the default tracking. So if you have a control that has some more complex behavior, you'll have to futz a bit more with that one. You have static text or edit text fields. You can have icons, you can have a picture. And then you can have a user item where basically you just install a callback and the dialog manager calls you. But that only works in dialogues, so is not really intended to be used for all your windows, and is in some forms limited in what it can do. And so the first thing I did was, you know, make this control class, and that also does things like when the window gets resized, then we call auto position in window on all the controls in a window. That means when we resize a window, I guess I can show you that. You will see a little more than you're supposed to, but hey. So this is a window with custom content. So these scroll bars are C scroll bar controls, which is the subclass of C control. And so when I resize the window, my C++ code takes care of pinning these scroll bars to the right and bottom edges and keeping them as wide as the window. Similarly with that push button, which is a C button control that I created, Hi, Tony, how's it going? Yeah, I'm doing fairly well. I just went outside for a walk and was completely exhausted or something, but I thought I might at least stream. So apologize if there's no camera, but I'm looking a bit like death warmed over. But I've made some great progress on this program, as you can see. So the thing here is that these subclasses can implement special behavior specific to a scroll bar. For example, you know, the page up and page down functionality. When you click the track, you can drag. The functionality for clicking the arrow button up and down. So all of that works. And they get resized in their window, as you would expect. So yay. Now, there's one problem. Not everything in macOS 10 is available as a control. And controls are rather limited. So there are two big libraries. You spend 10 hours running around on errands. Nice to see you're making great progress. Yeah, so I hope you got all the errands done at least. That's always satisfying, or at least a whole bunch. 10 hours is a good deal. So how I originally did this was just everything in... so how I originally did the controls was I used the reference constant, which is like a number field where you can just put a pointer to something, or rather just a number, but it's the size of a pointer, so you can put a pointer in there as well. And that reference constant, I set that on each control to the object, like to the C button control object or the C scroll bar control object or whatever. So I can, when I find out, okay, this control has been clicked through the Mac API. Wait, that is in here. Let's see. Mouse down. All right, it's in the window. So the window class has handle mouse down, and there at some point I looped over all the controls in the window and then asked, so I did a find control. Actually, not loop over all the controls in the window. I do a find control and say, okay, which Mac control was clicked. Then I get the refcon for that control, typecasted to C control, which it really is, and then I can call handle mouse down on it, you know, to run the code reacts to something. And for example, I use that in C button control. It actually calls handle command on the window it's in. And the command is just a number identifying each command. Love that sysbeep 007. Yeah, I saw that. One of my colleagues used to do that. Before, I was always like strictly adhering to Apple's guidelines, which was sysbeep 10 was like, okay, that's sort of the duration that it should have on like the original 128K under System 5 or whenever the sysbeep calls duration parameter was still honored and it didn't just play sound files, because before it just beeped. Hi Pilkey, no, this isn't Coco. This is classic macOS. It's really old shit with a lot of manual labor required. Writing your own events loop, uphill in the snow and barefoot. You know the story. It's actually funny that the duration hasn't done anything meaningful since Sound Manager was created. Yeah, it's But you know, 007 is still close enough to 10 because it's just octal 7, so it's 7. The beep sounds correct, and it's a cute number. Hi Ada, it's the cuneiform tablet of macOS programming. Yeah. Oh, subscription. Thank you. And of course we didn't get the alert because this idiot is on the wrong scene and nobody told me. I don't have a camera today, so I didn't actually notice it. I don't think I can give you the alert again. So let's do ta-da! Thank you for the subscription, Pilkey. Oh, I think we saw like the last flash of the alert the moment I switched over. Thought you were already subscribed. Well, you know, I never assume I know. You know, it's not that I'm making a big living off subscriptions or Twitch streaming or anything. I have a job that pays the bills, so it's fine. I don't really need the subscription, so it's just if you want to, you can. And yeah, and it gets you some fun alerts and emotes and things like that. Yeah, so the problem with this is not everything is available as a control. So I think on System 7, the only controls available were scroll bars, push buttons, checkboxes, radio buttons. Was there anything else? Pop-up menus. And I think that's basically it. And you can create your own controls if you want to. And you kind of had to in some cases because some seemingly common controls were not actually available. Oh, and you bought a pizza stone, so you can use it to bake pizza. That sounds cool, Tony. Post some pictures if you can. Send me some. Always interested in other people's pizzas. Ad-free viewing and emotes are the best benefits of subs on Twitch. Definitely up there, yeah. Alright, so the problem here is that there are two big libraries that Classic macOS has that do not actually have controls. That's the list manager and text edit. So the list manager kind of shows you like something roughly like this. I'm not sure. I don't think this is list manager. I think this is PowerPlant's re-implementation of the same thing. Well, list manager, basically it looks like this because I managed to make it work. So it looks like this. You have list items that can show text. You can actually show other things in lists, but again, it requires you to write your own drawing function to do that. It can show a scroll bar. Let's see if I can make it small enough. It's actually, whoops. Okay. Now we know that I still need to work out a few kinks. Oh, I know what it is. Of course. So my Unicode question will reply later. Actually, very good question. Thanks. So yeah. So the list manager is a fairly simple thing. The problem is it uses one or two scroll bars, depending on whether you only have vertical scrolling or you also want horizontal scrolling. So now you can create your own controls. I did this here for a slider. Wait, I think I can actually demo that for you. Filey window. Here, I can replace the push button with a... That's just C control, so it doesn't do all the things yet. And I actually haven't finished implementing the slider because I realized I probably wouldn't need it. Okay. That's... Oh. I commented out the wrong line. Why did none of you stop me? All right. Oh, hi, Masquerader. Thanks for coming by. Thanks for the lurk. Lurks are appreciated. So this is my slider control. The clicking and tracking doesn't quite work yet, but at least it draws something. And now, if you actually look at the code for that, it's a separate code resource. So if you look here in the output of that project, it's this CDEF, control definition function. And it just contains 68K code. I actually don't have the disassembler here. Interesting. Is that... Wait, do I have that on my hard disk? Can I install that? Applications, ResEdit, extensions, code editor, open, desktop, Macintosh HD, system folder, preferences, ResEdit preferences. And now we just copy all of these over. All right. Do we need anything else? KCS editor? Not really. Okay, quit. And now if we open this, you should actually get a nice disassembly. Yeah, you see actually the function names I chose calculate track rect, calculate thumb rect, calculate value from thumb left, handle draw, handle test, handle init, dispose, move indicator, all the things that I implemented, even the main function. So yeah. Oh, and there are even my patterns in here. Cool. So yeah, and if you look at this slider control project, it's a single segment compiled code resource. System folder is top secret. No, actually in System 7, it was still kind of a user serviceable place. Like they even had friendly icons for everything in there. Like you could go, okay, what extensions do I have installed? Of course, some extensions that you remove here could hose you a little bit, but most of these you could still remove and your system would still mostly work. This Apple menu items folder is actually one where you were supposed to put in files that you want to have available for quick access here. You see, I actually dragged my application in there a couple days ago. I should probably just delete that again. And now it's gone from the menu. Extension Manager was really helpful by the end of the classic era. That's true, yeah. That's what this Control Panels Disabled folder comes from. If you look in Controls Panels, Extensions Manager. Okay. So this is what it looks like, and you can just tick, untick any things that you don't want running. And then what it does is, for example, if you take a control panel here and untick its checkbox, it gets moved into control panels disabled. Similarly, yeah, with any other, like, you could even do that with startup items, shutdown system extensions. Where are the extensions disabled? Here, you know, like, those are the ones that are unchecked here. Here, those two are actually in there. So that's basically all that this program does. It moves those out of the special folders for the system and moves it into other folders that just have the same name with disabled. And then you restart, and then the operating system doesn't see the new extensions anymore. But if you want them back, you could just tick them on again and they will start working. And also you can save them, and they had built-in sets for, like, the ones that came with the operating system. So really simple but cool. And basically that was, a lot of these folders with icons were just, you know, there for you. Like, I think the print monitor documents is basically your print queue. I think so. You could just kick out things that were being printed. Stuff like that. All right, but back to our slider control. So it's not too complex here. But what it is mainly this main function, which contains a handle to the control that you're supposed to draw, so you can check, you know, like, what's the current value and the minimum value and the maximum value of the control, and then draw yourself accordingly. And then you get a message, which is a selector that tells you what operation it wants you to do. So it will repeatedly call into your main function and tell you, you know, draw the control. And, or, you know, hit test the control, tell me where the click was. Things like that. One funny thing is there is this old calc control regions call, and that had the, so again, like we did in other spots, there is this param, which is just a 32-bit integer, so the size of a pointer, that it just passed in, and it had a different meaning. So for example, in the case of where it tells you calculate me, like show me which area, and it may be irregular shaped, is the thumb of your slider, or which is the entire control. And so you have to typecast the param into a region handle. But in this older call that you might be called as, they actually set the high bit in this pointer to 1 or to 0, because remember, the original 68,000 CPU in hardware, like, the addresses were 32 bits in size everywhere, but it actually only used 24 of those. Like, the hardware couldn't address more, couldn't, you know, talk to more memory, basically. And so that meant they had these 8 bits at the top that were unused. And so what they did here was just they used the extra, the topmost bit, to tell you, like, if it's set, then it wants the indicator region. So the scroll bar's thumb, the sliding part. And of course, once Macs got better CPUs that actually were able to deal with more than 24 bits, they had to stop doing that. And so there's a second set of calls, calc control region and calc thumb region that have that split up, so you get a region handle in this parameter, and the message tells you whether it wants the entire control or the thumb. But anyway, so as you can see, if you create a call like this, then the control manager will call you, and the first time you're called, you will be called with init control, which is basically a constructor. And so at this point, you're supposed to set up your data structures. But if you were the list manager in a control and you wanted two scroll bars to let you scroll your content, then you would have inside init control, you would have to create these controls. And the problem is, you know, the control manager is just in the process of adding your new control for which you're being called within it, your list box control, is just adding this to the list. And at that point, you add a second control to the list. And Control Manager wasn't prepared for that, so boof, boom, blew up. So you can't actually create one of those control definition functions for the list manager, at least not if you want it to be scrollable. Unfortunate. Anyway, so when you compile this, it gets compiled into this resource file. And as you may have noticed here in my project, I don't have just my resources file anymore. I also have the slider control resource file. And that's why I can use this slider that's from a completely different separate project. Why I can use this in my window here. And it will actually be drawn here. And once I finish implementing that, it will probably also be slidable. All right, so that left me with a problem, because how do I create a list manager that is drawn inside my window? I couldn't make it a control, which would have been nice. So I went, okay, I need a second thing, a list of something, you know, of C++ objects that handle all the code, and that create the list manager data structure, which will in turn create the Mac scroll bar controls. And that's what this C window attachment is. So these are things that you can just create, and the window keeps a linked list. It has now a C window attachment pointer with a linked list of all the window attachments, and each window attachment has a next field. So it's basically like the controls are kept inside Mac OS. Like the controls also all have a next field, and you iterate over them, if you remember that from last stream. And so these attachments, just like every time the window is redrawn, I call, I go walk this linked list of window attachments and call draw on each one. Every time a mouse click happens, I call handle mouse down on each of my window attachments, and the window attachment can then itself check, like, is this mouse position in the area where my object is, so my list handle or whatever. And if it's not, it will return false, otherwise I'll make it return true. And if it returns false, you can actually see that in handle mouse down here. It walks over the window attachments, and then if handle mouse down, it just returns. So exits the loop and everything. So that's nice, and means I can you know, no matter what these objects use to actually present their thing on screen, they can just run their drawing code and hit test with whatever rectangle each object has. I also have a resized window from call, which is analogous to the controls, auto resize controls. And for that, I also extracted the auto positioning flags that I created in their own file, because they're now used by ccontrol and by the attachment. So that means I can now, and I have a utility function here, resized from old to new window rect. And here I'm doing this, what I last time said I should have done for the controls, which is I just take the old window size before it was resized, and pass it into this call. And so this call calculates, based on the old size and the current rectangle, calculates the distances of the object to the window edges, and then it looks at the auto positioning flags and goes, okay, it's told to, you know, like be pinned to resize with the window, so make sure that the top is still 10 pixels from the top, the bottom is still 10 pixels from the bottom, the right still 50 pixels from the right, and the left still 50 pixels from the right, or whatever I want. So I don't have the left distance, right distance, top distance, bottom distance saved in the objects anymore, taking up 2, 4, 6, 8 extra bytes that are not strictly needed. I also have activate and deactivate calls, so they can, you know, deactivate each other. And of course I have the set auto position flags, so you can actually tell it how to resize. Nothing really super special. It's kind of similar to how ccontrol is. And this allows me to create a CList Manager window attachment, which, you know, handles a list handle. So if you look into that, it creates a list, and I actually created with 3 items. So these data bounds are kind of like, how many rows and columns do I want? And usually say 0 rows and 1 column, and then fill it later when, you know, the data comes in that you want to show or something. But to start with, I went, okay, I want some text in there to see it. So I created with 3 rows and then set their data to 3 strings. First row, second row, third row, that was what you saw. And so I use lnew to create the list, all fine. It, of course, has a destructor where it calls ldispose to free all the data structures from the list again. Oh, and yeah, that's one of the special things about the list manager. It keeps data. Like, you can just give it a chunk of bytes for each row with an arbitrary size, and it will keep those around. But you can also provide, like a control definition function, there are also list definition function, which draw one cell, one row and column, like one box in a list. And you can, of course, create your own and make one where, for example, the first 4 bytes are the ID number of an icon to show, or even a pointer to an icon to show, and only then there is text or whatever you want. But we haven't done that yet, because of course eventually we will want to run to have a list with icons, because we want to list files. Then I have the draw function, which is also fairly simple. So it first erases the background to white, just to be sure. Then it draws the list using lupdate. which is like update controls or whatever. You know, it's the same idea. You give it the visible region of the port so it doesn't draw any unnecessary parts, and you tell it the list to draw. And then we also draw a frame around the list. Now here's the special thing. mlist rview is the rectangle of only the area for the list items. It doesn't include the scroll bar. And if you look up here, we actually here subtract 15 to account for the scroll bar size. So of course, since, you know, like the line at the edge of the list and the line on the inner side of the scroll bar have to overlap on screen. You know, there's only one line here, not two. That's why we only subtract 15. Yeah. And so what we also do is we inset it one to the outside, because of course our outline should be outside the list items. And the scroll bar is actually positioned like 1 pixel farther outside. It's kind of weird that they didn't just automatically say we'll also draw the box around it, but hey. Anyway, so that's the drawing code, fairly simple. And here's the handle mouse down, where, you know, no magic. We take the coordinate from the event, convert it into local coordinates of the window, and then say, is the point in that rectangle? And that's the bug we had earlier, because that's list rview. And really that should be box right plus equals 15, because we want it to also react and tell the list manager if it's a click in our scroll bar. Fun fact, when Scarab of Ra was made, List Manager didn't yet exist, so the developer of that game used multi-line text fields to make fake list boxes, and made them to work like list boxes by sneaky manipulation of selection ranges and a couple of other neat tricks, like drag gray region to swap rows when dragged, etc. Oh, cool. I mean, in a fashion, I think that's what HyperCard did. At least that's the image that HyperCard gives you. If you go into so let's go into HyperCard, make a new stack. Now it's mounting my native hard disk. That may take a while. Do 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 do. Okay. Let's create that here. List demo. So if you do a list in HyperCard, you actually create a text field. And for example, make it scrolling if you want a scrolling list. And they say, you know, like first, second, third. Let's make a few copies of this so we have something to scroll. And of course now this is just a text field. But what you can do now is you can say auto select, and that turns it into a list field. And now if you, oh, and of course you have to say lock text to go with it. And now you have a list. But you see, like, it's drawing slightly different, so I'm not sure, and it doesn't wrap anymore. As you see, it automatically checked don't wrap. And like, if you turn off don't wrap with auto select, it turns off auto select, and if you turn on auto select without don't wrap, it will turn on don't wrap. So I don't know if they're actually using List Manager here, or if it's, you know, completely hand-drawn or something. Or it could just be that they're rendering the text like in every text field, just without wrapping, and then, you know, just draw the selection. And you can even get a multiple line selection. And now you can just drag to select multiple lines. So I'm wondering what they're actually using for these lists. If it's actual list manager, if it's just, you know, a bit of custom drawing code, who knows? You didn't even think about HyperCard, but you guess HyperCard also faked the scroll bars? Yeah, I did check it. Indeed has a different size even in the arrow boxes. Yeah, like you can. It's yeah. I can't demo it here because this is System 9, so the arrows look completely different. But I mean, even there you can see the difference. If I collapse this window and close this one, if you put this here, I think you can kind of see now these line up, and this here is like it's 1 pixel difference in the width. It's actually 16 pixels, as you would kind of expect. And they're drawn basically in System 6 style. If you look in HyperCard's resources, you can actually... Can I drag this? Yeah. Let's see what happens if I drag this. Yeah, it works. If you look in, I think it's S-icon. Yeah, you can actually see the icons it uses for the scroll bar arrows. So just in case you wanted to know how they do this. And that probably makes it more likely that this isn't even List Manager. Because really, List Manager, you know, one of the main things you get from List Manager, apart from, you know, text being drawn in rows, which, you know, the text field already did, is you get scroll bars. And if you can't use the system scroll bars anyway, then why even bother using List Manager? So yeah, some crazy hacks in those old apps. All right, and so the reason why it's important that we add these 15 here before we do the point and rect check is that if we do not detect the click as inside anything relating the list manager, including its scroll bar, then this returns false. And if you look at C window, handle mouse down, if this returns false, we'll just go through the loop and end up here in clicked control. And so this will call find control, and will probably, you know, if I clicked in the list boxes scroll bar, then it will get me that control. And then I will go and try to get the C control from the refcon. And I did not create the scroll bar, like it was not created by a C control. So I'm getting whatever garbage data is in there. If I'm lucky, it's a null, because they're not actually using the refcon. And then I'm calling handle mouse down on some garbage pointer and crashing, as we saw earlier. And that's the reason why I also changed C control. So originally C control was not a linked list, but it is now. And my window, C window, actually has a mcontrols pointer to start of the linked list of these objects. Why am I doing that? Well, originally I just iterated over the Mac control handles attached to the window and did the same thing I did in that click handler, which is get their refcon and just assume that it was a C control that was written in there, which meant as soon as I added the list manager in there, the activate function crashed. Because if you look what the activate function does, where is it? Here. It loops over all the controls, which, you know, in the old code included the 2 scroll bars that the list manager had created, which weren't using the refcon to store a C control. And I'm calling activate on them. So basically that meant as soon as I created my window containing a list box, the first thing it gets is an activate event, because it's now the frontmost window, and it would crash the whole emulator. So these are things you have to think about if you want to write like a generic application framework or something. Like usually what people did was they didn't write frameworks like that. What they did is they wrote basically very specific code most of the time. So they would have had a struct for their window containing a control handle for each scroll bar they create in the window and things like that, and then would only deal with these, you know, and would manually have to remember to deactivate and activate each scroll bar and things like that. Which, you know, since I'm writing this framework, my framework will actually take care of that, and the app will just behave the way she should. It should. Okay. Me calling an application she is the German in my brain getting in the way. Because it's a different word, but there's a word in German called Applikation, which usually is more like the application of concepts, or it could be like a little, you know, little design element on clothing or something is, I think, also referred to as an Applikation. And that's female, because in Germany we just assign random genders to words. Okay, and now when we create this, we can click in the scroll bar and it doesn't crash. Cool. Now I'm trying to do the edge. Yeah. Still all fine. Good. And we have list items. Oh, and one neat thing. If I double click on a list item, list double clicked. So that's what the lclick function actually does. It returns true when someone double clicks a list item instead of just changing the selection. So yeah, so now we have this two-pronged approach, which is we have objects to make controls easier to manage, and we have the option to take things like a list manager list. Cool. All right. Oh, and one tip to you all. Remember to initialize your fields in data structures. Like when I created the when I changed C control to a list handle, either it was that or it was when I added one of those here, M controls or M attachments, to the window. I actually forgot to clear one of them out to null and had some random crashes. So that wasn't fun. By the way, just double check the scroll bar behavior on Mace. Mace is, by the way, Tony's emulator. The website is mace.software. Check it out. There's a cool blog with like lots of background information. Okay, scroll bar here. A maze on HyperCard 1X. It indeed draws the scroll bar using font 31756. Draw char I is used to draw an up arrow in scroll bar. Ah, yeah. We could actually check if that character is still in the font. I know that there's a whole bunch of things still done by the font. Where is it? I think it's an NFNT. Yeah. So let's see. Oops. Let's see. So there's all the icons you see in the tool palette in their variants like filled, and there is a bunch of cursors, and there's even the cursor for the fill bucket and for the mask to use for the fill bucket, which is fascinating. Like, you wouldn't think they would put cursors in there because, you know, cursors need a bitmap, a mask, and a point. So, like, if you see, like, this pencil tool, the hotspot, as it's called, the point where actually when you click, the click will be reported, is the tip of the pencil in the lower left. You see? But with an arrow cursor, the point where a click will happen is in the upper left. So they're always, like, centered on one of those fonts. And so I'm fascinated that he did cursors. Like, I would have expected the cursors to be curse resources, which they have as well. You know, the hand is just a regular cursor. So I'm really confused why it's not here. Whether that was just, you know, reused code from McPaint. And, you know, he didn't want to change it, and maybe the original McPaint came before the cursor manager had been, or before the cursor resource had been defined, something like that. This is the symbol they use on the debugger menu in the menu bar. Here's the highlighted version of the scroll arrow, at least. K and L. But I and J aren't anymore. So my guess is it's still the same font. But they removed those two because they moved them to the second resources. But apparently they still use the black versions to highlight them. I would really like to know what how that happened, you know? At what point did someone go, okay, I'll change these two from fonts, but I'll keep the highlighting? Like, I would have expected, you know, you just add two more icons of the highlighted versions and then get rid of all of them here. And here are a few more masks and cursors. And cursor masks again. And these are the different brush shapes. And that's interesting. That's the hand. That's not the hand in the tool palette, because the hand in the tool palette doesn't have a shadow. So that's the actual hand that it uses as the cursor and the mask. So at some point, this cursor was using the font. Weird stuff. But I mean, that's, you know, like, Bill Atkinson was the one who wrote the operating system. So there's probably, my guess is most of it is just, you know, he took code he already had from McPaint. Another fun fact about these custom fonts, if a font name starts with a dot or a percent mark, it's hidden from the append insert res menu so they don't appear in font menus. Yeah. Also used to hide actual drivers from ending up in the Apple menu when adding desk accessories to it, which you mentioned last stream. Yeah. Yeah, it's always fascinating. But, you know, there's some things that are really bizarre, like why is there a second copy of this cursor? And I know that HyperCard uses this cursor because you can replace this cursor with a different picture. Like you could just paste a cursor 128 into your stack, and as soon as your stack is opened, HyperCard will use that cursor instead. So, you know, this one is used. Why the other one is still in the font is anybody's guess. Like, I would guess it's probably a leftover from development of HyperCard even, because I think the curse resource is even HyperCard 1x. But interestingly, this font doesn't even have a name. So I guess empty strings, empty names are also not added. Anyway, don't save HyperCard. We didn't mean to make any changes. Yeah, so don't forget to initialize your fields. All right. So, so now here's the thing. We want, we're creating something like Finder, right? So, what we want is a window that lists files, which in turn, I think the first thing I will do is make a copy of this using our version control stack from last time. You can actually see it has all the files in there. So make a commit. All right. And now that we have this copy, I can later check that in. And now we can change the filey window, because really we've put all this test code in there, but we do not actually need the scroll bars here. We don't actually need the button or slider in here. We really only need the list. So actually, I think we just need -1. And that's it. And now we should have a full-size list in the window, of course. I deleted... There's a lot of ambulances out there today. Wait, we don't really need this either. We go equals window to Mac, and then portrect. Oh right, M window is wrong. It's just to Mac. M window would be the Mac window. Oh, so I can actually just say M window portrait. Now let's create this. Yeah. Almost correct. I think the -1 is actually not needed. Okay. Which of course means we're drawing outside of the rectangle that were originally given, which isn't quite right, but okay. You'll be preparing dinner at the same time, so jumping 50-50 between computer and kitchen for a bit. Have a nice dinner preparation. Okay, so we have a window here, and that has a list. So now we should probably remember this list so we can deal with it. So see finally window, protected, list, and so this gets attached to the window when you create it. So when the window is destroyed, it gets destroyed, so we're not leaking memory here. It's fine. And now we need to remove the code that creates the filler list items and make some extra code for that. So let's write the function first, I guess. Add row. And wait, I think it's a short anyway. Let's lists.h is where the list manager lives. And now we say add column, add row, del column, del row. Auto scroll update, where is it? I'll click add to cell. Clear cell, get cell, set cell. Data pointer short length, yeah, it's a 32K limit anyway. Okay, and what does add cell do? We had that add row. It just adds a row, it doesn't actually. Okay, so first we add row, then we set cell. This is a short as mentioned. What is the data typed as? Const void. Okay, yeah, we're fine. Add one row. And now we need the row number. And I think the row number can be found only in the by reading the data structure itself. The list record. List bounds visible? No. max index? Huh. So how do I find out how many cells are in a list? Get cell data location, draw set cell lrect. What's this? Okay, so I guess it's inside Macintosh time again. So I need to dig out inside Macintosh, more Macintosh toolbox. I push this button and hopefully don't forget to push it when I'm done. And now we're looking for lrect. Too many functions named something with lrect. lrect. To find a rectangle that encloses a cell. Because the list manager automatically draws cells, few applications need to call this procedure directly. Okay, that's just an actual rectangle. It's not actually the dimensions. Cell size. Oh, by the way, interesting thing is resizing a list view is a bit more involved than you'd first think. So there is an lsize function that takes a width and a height. Noticeably no position for the list. I didn't find any called like lmove or something. So what I did is just I resize it because that, you know, changes the layout of the cells. And then I just assign that resized box back to the list's view rectangle. Which means means that its position changes, but its size has already been changed, so it's fine. And that way it will draw in the right location next time. But also, the cells, since we only have one column, we need to, or rather, like, even if we had multiple columns, like, we have to handle column resizing ourselves. So usually you would expect the last column to at least be made wider to fill the entire width of the list. And that's not happening here. So what I'm actually doing is I'm setting the horizontal cell size to the width of the window. And of course, before and after that, I invalidate the rectangle for the entire view, so that it gets redrawn, or rather, not view, like for the entire list and its scroll bar. So that, you know, if, you know, the view is somewhere in the middle of the window and we resize the window, then you might get, you know, like two overlapping rectangles, basically. But still, each one has like an L-shaped area lying outside of their common area, so you need to redraw both of them to get both the spots where there is no longer any list redrawn with background pattern or whatever, but also, of course, the spot where there is now list where there wasn't before needs to be redrawn as well. Alright, I'll get cell, add to cell, cell size. Oh, we could call L activate actually. Let's quickly add that here while we're there. That should look a little nicer. Update, auto scroll, scroll, set drawing mode, L size. That's the one we use to resize it. Next cell, last click, get select, delete row, delete column, add row, add column. I guess we have to look for the list. Is it called? That's a typo. List rect. Interesting. I never noticed typos in Inside Macintosh before. I was impressed how few typos it had. I guess that shows like back when I actually read those books back to back. My English wasn't that good, and I was probably so confused that I didn't notice. So that's the display rectangle. Indent distance for drawing. Size in pixels of a cell. Boundary of visible cells. Click time, mouse lock, click loop, last click, refcon list, devproc, user handle. Data bounds. Boundary of cells allocated. That's what I was looking for, I think. Alright. What? Your English was ever not good? Ah, you should know of all people. Okay, so now we have to go to add row here, and say mlist dot data bounds wait, first let's just set this to 0. Doesn't it look like a cute little owl? And then say cell vertical data bounds bottom. So the question is now, if we're unfortunate, that we'll insert it below the bottom cell. But we'll see. It doesn't really... Does it wait, it should describe them. F3. It's... I think it was a good idea. Like, before I started the stream, I went, you know what? I should put this Inside Macintosh on the right half of the screen, because most of my source code windows are on the left side. So even if I'm covering the project window behind it, you know, that little thing, at least you will be able to see the source code that I'm referencing. And kind of having both up on the screen sounds like a good idea. See, the only fields of a list record that you need to be familiar with are the rview, port, cell size, visible, and data bounds field. The visible field specifies... Wait, what? What does the visible field specifies which cells in a list are visible within the area specified by the rview field. Oh, that's a good thing to have. right, and bottom, so that each is one greater. And I'm suspecting data bounds will be the same. The data bounds field located near the end of the list record, that's a nice way, a nice call out. I guess many people went like, I can't see it because it's so far back. But it seems like, a fairly important thing because you need it at the beginning when you start filling the list. Specifies the total cell dimensions of the list, including cells that are not visible. It works much like the visible field, that is, its right and bottom fields are each one greater than the horizontal and vertical coordinates of the last cell in the list. Perfect. For example, if a list contains 4 columns and 10 rows, the last cell in the list has coordinates 3, 9. The list manager sets the data bounds field to 0, 0, 4, 10. And so that means here, this is the new cell where we will insert it after we've added the row. Right. Let's see, I'll add row. The number of rows to add, the row number of the first row to add, yes. The list to add the row to. So basically, we just say cell V here, so we add a single row at the end of the list, and then we set its data, and now that index is actually correct. Isn't that nice? And now we have to add this method. That should probably be at the start, because that's, I always try to order my methods when I write code in like, what will people be most interested in? First, you need the constructor to actually create the object. I usually put the destructor next to the constructor just, because they're related. And then, you want to add some rows, so that would be the most obvious thing to do. And then the rest of the methods are kind of usually, you don't have to deal with those. They're just overrides of stuff in the window attachment to make things work. But, it's more likely that you will want to update, to override, to change how its drawing behaves, or maybe you want to do something special when a certain modifier key is pressed or something on the list. So those are like the first ones. And activation and deactivation usually you don't want to mess with. It's funny that List Manager allows you to have cells in 2 dimensions, so you could basically make a cheap one-man MS Excel clone using it. Yeah. That's basically what it is. The problem is just it only has a cell size per table, not per column. So it's not really useful for, reproducing like this user interface. Because here you want one big column for the file name, and then a smaller one for the code and the data sizes, and then a similarly small one for, like, does the debugger know about this file? And for this little pop-up menu to trigger some actions or view headers it uses, stuff like that. For that project navigator, one would probably use a custom LDEF which just handles those columns. Yeah, I guess that's what one would have done back then. of course, this is Code Warrior, so we know that this is implemented with PowerPlant. So we know it's not even using List Manager. So it would be single column from List Manager point of view, but LDEF would handle the fake columns in it. Yeah. And I mean, it's okay because List Manager selects cells separately. So like in another column, a cell, you can select a cell in a different column but the same row. Whereas here, you only need that one selection for the entire row. And you don't care about only selecting the code size. So, yeah, that's what you would do. Of course, they actually don't have that here. Yeah, they don't. Like in later operating, or even in do we have any nice here. Yeah. The modern, this is a data browser is what they called the new replacement for the List Manager that arrived with I think System 8 or maybe System 9, but it's this, it looks like this. This is the look of the data browser. And here you see you can click between columns and resize a column. And you can click a column to sort by it, and it will actually highlight the column by which you are sorting, so it stands out a bit. And of course, so there are some things that you could do, and that would be a little more difficult if you did them with a list definition function. Because basically what you would have to do is you'd have to have a shared data structure somewhere that the list definition function can access that holds like the width of each column. And then when you resize the headers, you would have to live resize the list. By the way, some classic cases for two-dimensional list manager are ResEdit 2's default icon view, where all resource types are in icon grid, and Civilization's Civilopedia topic picker. Okay. ResEdit's icon view is... Well, I guess you don't really see it. The thing is, if you use List Manager for ResEdit, it's kind of yes, you can use that, but you have all sorts of special cases to handle. So first, you need to yourself calculate how many icons fit in one row, and then make that many columns. And also, if a cell is empty, you have to deal with making sure that it can't be selected. And then, of course, this is a custom list definition function that draws an icon and this box with the resource type around it. You don't get that much. I guess what you get is maybe type ahead selection. So like I can press I and get to icon, V get to version, M get to menu. And I guess, the arrow keys, yeah, I guess there's a bunch of things that it does for you. But it still seems kind of, I would almost just go and implement it myself completely and not bother with List Manager. Because you're already replacing the complete drawing code, and you're calculating the layout yourself. You also get auto scrolling. That is when you scroll list while holding down. Yeah, that's true. Although I think... no, I think that was the framework I was using at the time. Yeah, I guess you have to implement a bunch of scrolling behavior. It's not too bad, but it's kind of more convenient that way. I used one framework, C++ application framework at the time called Mac Zoop, like ZOOP. And that actually had it had a scroll view built in. And that scroll view actually had an auto scroll method. So you could just tell it, I want this rectangle visible, and it would scroll there. Also, list manager handles multi-selection in this case. Yeah, true. But I mean... yeah, I guess... oh, what does it... yeah, and I guess that is kind of Excel style. Like, it always builds a rectangle. It doesn't, like, select the items in sequence. Yeah, I guess... maybe there are some things that you get from List Manager after all. Which, by the way, is still missing from Maze. Well, get to work then. No, but it's amazing, like, all the subtle behaviors that classic macOS had, you know, in the stuff it provided. But also how much you still had to do by hand, where you would have thought, why didn't they integrate that into the system? Everyone has to write this function over and over again. I mean, even if you look at there was this sample code called More Files that many people used. The guy who made that, Jim Luther, is on Twitter. He posts some interesting things sometimes, though rarely retro stuff. But that was basically Apple developer support source code. And it's really weird that none of these functions actually made it into the operating system. Like, a lot of these functions, you know, those were file manager. Like, the functions file manager was missing, or more high-level versions of certain things in the file manager. So, like, a function that just, you know, did an operation that many people got wrong. Like, there was a function there to copy a directory from place A to B, and, you know, making sure that the resources and the data fork came along, and that all, like, the type and creator code and date and all that stuff is transferred over correctly. And I think it took until macOS 10 that we actually got functions for that in Carbon. I don't think we got, like, fscopy object, or did we? I think we might have gotten it at the back end of macOS 9 as part of Carbon Lib already. But that's about it. So it's really it's really fascinating, like, how long this chunk of source code was just something everyone downloaded from Apple's site and copied into their project and then used the calls, where Apple could have just thrown that into their operating system and made it available to everyone. I mean, there were a few functions in More Files that, you know, were for backwards compatibility. So basically, like, okay, if you cannot use the new system call, then, you know, make these manual calls instead, which, you know, get it mostly right on the older operating systems, but Otherwise, use the new one if it's available. Those, of course, you need as source code in your app because there is no source code in the older versions that you could call. But yeah, still feels a little weird. Okay, so we now have the list attachment. So now we need to change this to 0 rows again and delete these calls. And we can probably get rid of all the printfs in here as well. And now, whoops, closed the wrong window. Are all frameworks just made by people using the previous framework and thinking this abstraction isn't abstract enough? That's fair point. I think that's a pretty good description, yeah. It's definitely like you build it up in layers. The entire operating system. So yeah, there's someone, like that's how you would start an operating system. Like you would first go, okay, I need when the computer starts up, it will look at some spot, and that's already very simple code someone has written, or very simple from the perspective of compared to the rest of the operating system, but very complex because it deals with some hardware specifics sometimes. But like you have the bootloader, assuming that's already there and in your computer, and then it finds a file on a hard disk, and that already is a complex thing, like how does it needs to be able to read a hard disk, needs to find the list of files, find a file, compare the name, and then find where the actual data for the file is, and then somehow get that put into RAM and run it, and then once you have code just running, once you turn on the computer, you go, okay, now it would be nice to not just be able to run code, but maybe to have different processes. So you need code in there that can, find another file on the hard disk and put that into RAM too. And then you say, well, I can run one process after the other, but, I would like to, run them with multitasking. So you have to write a scheduler that knows which processes have been loaded into RAM and occasionally switches one out and switches another one in and gives it some time to run and then switches it out again and another one in. And so you're building it up until you can run processes. And then you say, okay, now I want to output text to the display. And most displays, I think, still have basically or actually don't know. Like at some point, originally displays had something built in where you could send them characters and they would basically show them on the screen. So, like, depending on which display you attach to your computer, you got a different font for whatever output was on your screen. And then they added a graphical mode where it was like, okay, you could send like a sequence of characters to your display and to tell it, okay, I don't want to display text. And, like text on a display, there was no scrolling, no nothing. It's just the display, and it's a grid of, what was it, 80 by 40 lines or something like that. So 80 columns of characters by 40 lines. Or something like that. And then you know, you build it up step by step. You have text, then you have a graphical mode. Then you go like, I would like fancy font rendering. So you write a library that generates the pixel for each font and lays out one character after the other and puts it on the display in graphical mode. And that's basically what a Mac did. It didn't have a text mode. It was always graphical mode. And then you go, you know, instead of just showing text and maybe a few shapes to illustrate the text, I would like multiple windows. And so you go and say, okay, first I need to be able to just draw into a rectangular area on the screen. And if I even try to draw outside of this rectangular area, I want it to be cut off. And then you say, okay, not just a rectangular area, but actually like an area of like L shape or something, because it's a rectangle with another rectangle on top of it, so a covered window. So you add clipping and arbitrary clipping, not just clipping to the screen edges. And once you have that, you can create windows. And then you go, okay, I have windows that can have content, but I still need to draw the borders myself. So someone went and said, hey, I'll make you a library that draws the borders around the windows and maybe even handles the moving and things like that mostly. And you just keep piling it up and piling it up until it's finally abstract enough for you to get some work done. Yes. But it's a great summary, yeah? The abstraction isn't abstract enough. That's basically how programming works. Let's see. Okay, this one doesn't really know about that class yet. List manager. No, wait, that's list manager. I want my window. That has the list manager. Good. It doesn't need button or scroll bar anymore. And now here, list. Let's just try this. Add row. And now string and string length string. And now we add a few more lines, maybe even all right. Oh, it's not a const void, is it? Okay, const correctness. Oh, this one. Of course, since we don't want to write to this pointer, it should be a const void anyway. Oh, and now string.h. All right, and now we've added a bunch of items. Okay, so now we've made this a little more generic. Now, of course, we want our list not to be a list of items, but actually, and now it gets a little difficult, because we want a list of hard disks first, in our file window. That's basically, you know, what the desktop shows. All the hard disks that are inserted. We can always move around the code and add an actual desktop if we want, but right now I was just going, let's make a application that lists a bunch of files, and we have to start at the bottom, which on classic macOS means all the hard disks. For that, we have inside Macintosh the book on files. I actually looked at these calls earlier because we haven't really done that part yet, but these are not related to what we're doing now. These are just, this application framework has like one missing thing, which is if you double click a file in Finder and start an application here, it doesn't actually open the files. And in reverse, if you start it without any files, it doesn't actually open any a untitled window at the start, you know. And really, this app will never be launched since it's a Finder replacement, you know. It should never be launched by Finder. Nobody should tell it, open these files. Okay, and the thing is, you usually in modern macOS and even in System 7, you would do this with Apple events. But of course, we want to be compatible with System 6, as, you know, we want to go as far back as we can. So we want to use this count app files. And I mean, what we know is if count app files, wait, it's and the message, okay, so they're both output parameters. Is that somewhere in here? Maybe it's in finder.h. Don't we have game sound? Interesting. Desktop audio. Bing. Let's see.
Uh-oh.
Ah, now we have audio. Not that this is good when I'm searching. It's actually nice to have it more quiet, but okay, I don't actually know which header is this in. Why am I getting sidetracked here anyway? Application and launch file routines, yeah. It should say, well, actually here at least we have the C prototype. It's both shorts, that's nice. Still don't know what header. Oh wait, but I can system headers segload.h. That's an interesting place to put something like that. I think we were including this. Yeah, we are already. That's nice of the CodeWarrior template. Okay, so short, what was it called? request count. Okay, count up files. Request count. If count equals 0, because I think I've already prepared a delegate method. What's it called? Open untitled document. Here. Else. For short x what count app files, get app files. The index parameter indicates the file for which information should be returned. It must be between 1 and the number. Okay. That's what you get for using Pascal as your first language. Everything starts at 1. So x less than same count plus plus x. All right, and now we do get app files x it's called app file apparently. And now we have to find out. Oh, and then we need to call clear app files. For each index. Okay. All right. Now let's see, application files record. Let's see, we have a... So this is nice because this version of Inside Macintosh already has a C summary section. Which means at least they listed it, but all the sample code is still Pascal only. Application files report. Volume reference name, file type, and file name. So it's basically an fspec by any other name. Huh. Okay. Whoops. So let's just do this for completeness sake, and so you see how one would usually... So this API comes from the day of Single Finder. So before macOS had multitasking. So that meant, you know, in Finder, you select a few files, you double click them, and they start up your application. Your application goes through the app files and either opens or prints these documents as requested by Finder. And then once you've done that, your application is running, but Finder has been quit, of course, because only one application can be running. So there's no way for anyone to double-click another file in Finder that would need your application to open files. So, so you didn't need anything more. It's the moral equivalent to, on Unix, where you just pass 5 files to an executable as parameters as you launch it. And then it opens those files. But as soon as you have multitasking, of course, you're having a problem. Because then, at any point I can go back here and double click this file. And CodeWarrior then has to open this window. This was very fast, but you saw the switch back to CodeWarrior at least and saw that there was the right window in front. But yeah, so the big issue with that is you need a second mechanism for the Finder to communicate with the running application and tell it, open this file. And that's why System 7 added Apple Events, which was a way to send arbitrary messages between applications, but 2 of the messages were open documents and print documents. And the nice thing about them is they just come in as events via wait next event. So they're not parameters that your application gets at startup. And that in turn means you can handle both cases the same way. Which is, I think, very clever. Okay, files.h, fsspec.
Uh-oh.
fsspec. So interesting. This is an old style. So app files is not even an fsspec. It's an old style from the, because let's pop up the documentation again. As you might see here, you get the volume reference number and you get the name and nothing more. Usually you would get a number representing the parent folder as well. But you're not getting that here. Did you mention yet, by the way, how the mechanism that passes those launch parameters from pre-System 7 Finder to application works under the hood? I don't actually know. I would have expected it to just be, some... Well, either basically I would have expected it to just be a hidden parameter to the main routine, because Mac applications, classic Mac applications, do not take parameters. They're not launched from the terminal, so there's no way to give them additional arguments. So what they can do is just they can define the entry point of each application to contain app params, for instance. That would have been my guess. But then, of course, how do you tell Finder? But I guess, you could just... The thing is, classic macOS doesn't have memory protection. If you give me a memory address that lies somewhere in Finder's memory space, my application can just change data in Finder. So my guess would be, they just pass a pointer when the application starts up, and that then gets used for that. But I don't know. If you know more details, I would be interested. So I think that fsspec has the vrefnum and the par ID. So file vrefnum equals app file vrefnum and block move from app file fname to file name and app file.fname 0 plus 1. That should copy that. And just to be explicit about it, file par ID, parent ID. I think I'll just set that to null and it will kind of magically treat it as the right thing. It's really cool. Finder allocates a handle with appparm_rec type and puts the list of files and the action open or print there and stores that handle in low-mem appparm handle global. Then the segment loader during code 0 loads it, reads the handle from the low memory global, and puts it into A5 plus 16. Even more interesting, there are 4 handles there. But this was the last one used. A5 plus 8 and A5 plus 12 were used in early days for standard in and standard out on classic macOS. Interesting. I'm actually not sure if MPW tools use those 2 pipe handles for anything. So those count app files, etc. just take that handle from A5 plus 16 and iterates it. Okay. Cool. So A5, for those who don't know that, is a register on the CPU. And as far as I remember, A5 is the register where the Mac operating system kind of stores the information about where it's loaded your global variables and things like that. So you can just, when you want to get to a global variable, just say, I want my global variable, and it is at A5 plus 10 or something like that. And then that way you don't have to know at which spot in memory you have been loaded, because on macOS, of course, you didn't have a memory management unit, so so you know, it didn't remap any addresses. It was just wherever you were loaded, there you were. And to be working, anything that had to be global would have to be relative to something that you know. Like you can, you know, compile the address so the global variables are like at the start of your program or something. And then you can have a relative address, but then that whole program has to be in one contiguous block in memory. And of course, to save memory, macOS actually does multiple segments. So if you look here, I have one segment sources, which is stuff specific to my application. So it's not really a good use of segments, but it's just a tidy way to clean things up. Then I have one segment for app framework for my application. And then I have one segment Mac libraries and one ANSI libraries, which, yeah, anyway. And if you look at my program here, here are the code resources. That's what this stuff gets compiled into. And when you look there, there's a small one that's basically the loader. That's the first one that the operating system loads. And then you see sources, app framework, Mac libraries, ANSI libraries. So, for example, if we look, let's just do that because it's my favorite thing in the world to do. If we look at how HyperCard does it, you see they have a whole lot of code resources. And for example, they have port paint and hyperpaint. So that means they have different libraries for components that you may or may not use. So for example, there's a compact stack code module. So compacting a stack is built up of multiple cards. And so if you delete a card, it just leaves a gap in there. And when you make a new card, if it fits, it will insert the new card in that open slot. Because otherwise, whenever you deleted a card, it would have to take all the cards behind that one and move them up. And if you have a card that is a database of like 50,000 records, then, you know, deleting a single card would take ages every time. And since usually you delete a card and then you create another one, usually the empty space gets reused pretty quickly. And there is a command in the file menu called compact stack that will actually clean up those gaps and do the moving to make your stack as small as possible with the current content. And since, you know, most of the time you will probably not be compacting a stack, this is a separate segment. And so that means if you just start HyperCard, use a stack, and then quit it again, this code will never even get loaded from disk. And that's the general idea. You see here there is an icon editor, or hyperprint. So if you never print anything while using your HyperCard stack, then it will never load that code. If you don't edit any icons, it doesn't need to load that code. You know, so, and then there's actually a separate one for HyperTalk and a talk compiler, support of external commands, you know, lots of different blocks. Yeah, and so since you have these segments, you can't just go and say, I put my global variables at the start before my source code. Because then when, you know, if you want to access, for example, here in my app framework, I have the application. And the application, I actually hid this, so this is not a problem here, but this application has a G application where the application object, once it has been created in the main function, gets stored. So that if you want to, you know, request some information from the application, you can just say G application blah. And so now, what if my Filey window actually wants to access that? It can't, because it doesn't know at what address it got loaded. And so that's why you have a 5 relative addressing. And if you remember my stream about making code resources, about you know, I had a problem there where I couldn't make global variables work, and so certain commands that used global variables would also not work. And I have the same issue actually here in the slider control, because that's also just a code resource. And what you'll see here is that here is ANSI 2i C++ A4 68klib. So it's not just the ANSI library with 2-byte ints for C++ and 68,000 CPUs, so not PowerPC CPUs, the library for that. No, it's actually the one that uses A4 to store its globals. And that is important because A5 is used by the application. So if my control here gets called by the application and then calls back out into the application somehow, triggers some application code, we would have a problem if it used A5. And so that's why basically you have this A4 version of the lib. Oh, sorry. Didn't see that. So here, ANSI 2-byte integer C++ A4 68K lib. So that's the project. That's the slider control. That only has a single segment. And now, if we look at our application, that has one segment sources, one segment app framework, one Mac libraries, and one ANSI libraries. And I think that was visible on screen, wasn't it? How filey? Yeah, the code resources were at least visible. But those are the same names: Mac libraries, ANSI libraries, app framework sources. So for example, if I know that I rarely call C standard library stuff, you know, then it makes sense to have the ANSI libraries in their separate segment. On the other hand, every time I want to printf something, and that goes out via the SU window, but it also requires me to call printf, which is in the C library. So having those in the same segment makes sense because I will need both together anyway. You had to do a crash course for this mechanism to get Fool's Errand post-game finale animation to work, as it depends on user launching the finale document from Finder using the Fool's Errand application. Okay, interesting. I remember you mentioning something in, I don't know if it was a blog post or in a chat message, but where you had an application that launched a document via Finder in another viewer application. And since your emulator so far was only I emulate one application and it didn't have a Finder, there was a problem there. Is it that same situation or a different one? Yeah, okay. The memory limitation of the original Mac 128K kind of forced the Mac developers to implement the segment loader system. With such little memory, only a very small amount of code could be kept in memory at once. With that dynamic load seg, unload seg, all the loading happens transparently to the app developer. Yeah. That's app and developer, sorry. Okay, so we were, inside the application. Yeah, and here, this creates an FS spec, and now mdelegate open document file. I think that's it, right? Open document. This should probably be a pointer. Let's see if it compiles. Oh, I still have ResEdit open and have my output file open. That's of course. Okay. So what you see now, there's something different now, because now it realized the application has been opened without a file and immediately gave us a filey document, an untitled one. So that's nice, and we can get a second one if we want to, of course. But at least we don't have to command N every time. So hey. So that was the only part that was really relevant. Basically this one. too filey, but if I ever build another application with this framework, then I'll be happy, although it will be untested so far, that it can open files. Alright, so we have this window, it adds elements. Now we need to list files. Let's see if there is anything. Wait, what was that? Maybe cat search is the fastest and most reliable way to search the catalog file of an HFS volume for files and directories satisfying certain criteria. The cat search function returns a list of FSPEC records describing the files or directories that match the criteria specified by your application. Sorry, I'm just trying to get more comfortable in this chair. Putting up my feet, things like that. However, pbcat search is not available on all volumes or in all versions of the file manager. Okay, lots of info, but get cat info. Or actually, what we want to do, of course, first is we don't actually want to search for files right away. We want to search list volumes. Oh. Okay. F is a root parent id is what it really... That might be something we should remember. I forgot that I turned off copy and clipboard synchronization between the what's it called? Between the emulator and the operating system itself, so I can't copy from inside Macintosh right now. Okay, that's all. Let's see, cat search. Get information about a single catalog file entry. Search for volumes catalog file for files or directories. Supports cat search. I should probably learn use that to check before I use it, but I'm just going to assume it's available for now. I should probably just oh wait, we had a command that listed files in our HyperCard exploits. So we've already done this. X files, I think that was it. Let's see. Let's hide you again and see what that does. Get vref num and dir id from path. We don't really need that. What do we have get? Okay, basically we need this loop and we need this function. Just, yeah, and that does pb get cat info sync. Right. We don't need that anymore. Dir path. Wait, doesn't the C info pb rec? Let's search for that. Does that have a pointer, string pointer? Nope. Okay, so it doesn't of its own spit out an fspec, but I think that should be fine. By the way, if you need to at some point iterate volumes on a system, you can do it with get vol info. Ah, okay. Yeah, that's probably the first step at least. We will need to modify this code to list files later, but let's see, get vol info. Oh, get v info, I guess. Come on. Erase disk, not really what we want to do. Get v info. You can use the get v info function to get information about a mounted volume. The drive number of the volume for which information is requested. On output, a pointer to the name of the specified value. The volume reference number of the specified volume. That's also a return parameter. And the available space in bytes on the specified volume. That's fascinating. Okay, let's see if we can maybe find the C language definition here. Okay. I guess that loop actually I can probably just delete this. C name from the above pb get vol info. Always forget the pb. Well, I also have get v info. So I don't really want a param block if I don't need it. So get v info should be fine, right? Or is get v info like System 7 only? And I'm just writing code that I'll have to rewrite in when I try it in MiniVMac or so. Okay, OSR equals get v info dir index The fun thing is that I think file names at least are limited to 31 characters. So I could use a stir31, which uses less storage, but doesn't really help us much. And since we're feeding it, and I don't know. Doesn't really make a difference, but should probably be stirs31. I need to check some of those are glue routines added on top of the traps. Yeah, I wouldn't be surprised if get v info was one of those. Let's see, if error equals no error, then add row vol name +1 full name 0. So that should get us a list of all the drives, and then we'll let the remaining, we'll leave those just so we have something to pad it out a little. And let's see what happens now. Oh, dir index. Can I actually... Okay, short max is probably in limits.h. Okay. That didn't go too well. Oh, I forgot to exit. Dang it. Okay, I'm hosed. Okay, task manager to the rescue. Because it's looping, well, we'll probably crash out of memory soon anyway. Or breaking some index. The problem is I did the loop. Looks like by spec, get v info doesn't do indexing. Drive numbers instead accept only drive numbers, not indexes that are guaranteed to be sequential. If you unmount a volume. Okay, so I need the PB version. Okay. Well, let's first shoot down end task. And let's search for the paramount block version then. PBH get v info. Is there any get volume free space? It's funny, there's 3 ways to identify a volume. Index, drive number, and vref num. Yeah. I honestly, I get vref num, a sort of stable number. And I get index, because you want to be able to list them. But, why is drive num just... Like, is it the same if you have, like, you know, if you have an LC with 2 floppy drives and no hard disk, is the drive number for whichever disk I put into the left one always 1 and the one in the right one always 2, or what? Looked like that on the PDF. The routine is pbh get v info. Yeah. pbh get v info. Okay, that's the wrong one. This one is what we want. Okay, hparmblk. Okay. And then pbh get v info, and async should be false. And we don't need these anymore. And so now we have to find out how to set it up. You say IO completion, 0 it out. I think it should be zeroed out if I use the 2 brackets. Unless that's a C99 thing or something. Name pointer and IO vol index. Well, I need to get the vref num out, right? Or does it just... Wait, it's just an integer, it's not a pointer, so I can just read it, I guess. Okay, so IO vol index block IO vol index. I can just count that one here, right? Don't even have to. Vol index equals 1 less than short max plus plus else break. Oh no, actually error, not no error. Break. That's nicer, I think. Paramblock volume param. Well, actually, I want the name right now. To show it, so IO name putter. Okay. That should be it.
Uh-oh.
What's the type Come on. H paramblock red. It's here they do parmblock, and then here they do paramblock. Seriously, decide on what you're going to. Oh, it's which part is it? I open volume param.
Uh-oh.
Of course, it's a union of several types here. Might be the name weirdness is a relic from 8-byte name limitations from early Pascal compilers. Yeah, I don't know, yeah. Oops, forgot that one. Huh. That looks good. Macintosh HD, this PC, data, gluttony, mist, stacks and flops. But why is the order different? And the rest. Okay. So now we have a nice list. Now, here's the thing. The nicest. Whoops. Let me just hide that one again. Before I forget that it's still open. The audio gut is how they're ordered on the system VCB queue. Yeah, but like, why is it different on the desktop? I guess Macintosh HD at the top is because of the boot drive. But then, like, what order are they using? And is there a way... Oh, wait, is that by name? By kind. But I guess that probably means by name. So Macintosh HD is first, and then S... L... M... No, data... It's not alphabetic. Might be finer. No, it's sorted. It's sorted by kind. So there's... And the thing is, it's not alphabetic. Because M, S, and D should be first. D, G, M, S. So it's a bit weird. But is this alphabetic? D, G, M, S? Yeah, okay, so at least we can argue with that. We have the system disk first, and then alphabetic. Is it... What if I do by name? Huh? Hasn't changed? from system point of view, when a new volume is mounted, it's always added to the end of the queue. So if it's unmounted and remounted, it goes to the end of the list. Yeah, but mine here is alphabetic. That's PBH get vol info. So it's... Shouldn't those be in a random order then? But the ones on the desktop are some seemingly random order. So why am I not getting that order? That's kind of what's confusing me. But I mean, you know, alphabetic is a better order, so I don't have a problem really with it. I'd just be curious what logic Finder is following. Necessarily random, depends on yeah, but seemingly random. That's what I said. How the system under Sheepshaver mounts those disks. Yeah, basically it would be interesting. Yeah, basically it would just be interesting to find out what order Finder is using for these disks. Because even if I say by name, they don't have a sensible order. I mean, one thing I can check is my Sheepshaver preferences. You won't see that, but interesting. So the alphabetic order is... So basically the order I'm getting here with Macintosh HD at the start, then DGMS is the order how it's mounted, like how it's listed in the Sheepshaver preferences file. So I guess what we could do as a little test, first let's get those, get rid of those. Then do a quick shutdown. And then let's put S as the second one. I'm kind of reluctant to tell Sheepshaver to like if I move Macintosh HD, I think it won't find the boot drive anymore. So I'll just change the order and start Sheepshaver again and see if that is the order my list is in. So at least then we know it's not alphabetic. Macintosh HD. Yeah, now stacks and flops is at the top. Data, gluttony, missed. Yeah, so this is definitely mount order. And Finder shows something else. I'm sure someday we'll get Open Finder so we get to replicate the exact behavior. Yeah, but so this is exactly the order I specified in my file, and my guess is it mounts the boot drive, then mounts the fake this PC drive, that, you know, lets the emulator access the host operating system's files, and then those are just the remaining ones in the order in my settings file. So this is not alphabetic, it just happened to be. Okay. Let's quit this, and let's quit this for a moment, and let's make another backup. This startup screen of the unregistered Stuffit version, where you always have to click not yet, and sometimes the two buttons change places. That's a really, it's a mean way to do it. I mean, it's, you know, fair. You know, I haven't registered it. But, you know, also, I don't think I can buy a license for Stuffit 5 anymore. Alright, so we're pretty good here, I think. So now we would list files. Or do we want to use icons? So here's the thing. You really want all your file management windows to behave the same way. So although it's really nice and easy to just fill these windows with you know, fill those windows with these file names, you kind of want to build in an abstraction so that you can have one window class that does everything, you know, related to showing the files, like, you know, sorting them, you know, opening them, whatever. But of course, to do that, that means we'd have to make the directory listing different. On the other hand, what we could do so, I mean, I can put just both file listing things in this one function. I don't think that would be a problem. Then I don't need some random extra class whose only job it is to list files. Because it's really what we output here at the end, whether it's just a row containing the name or whether it's an FS spec for the file or something, that, or for the volume, that shouldn't really make a difference. Do you plan to have also a list for volumes in the same UI? Like, at least right now, I mean, in the end, it would be kind of nice to have something that kind of looks like Finder. So with a desktop maybe, or something desktop-ish, or have a separate window for them. Here's the, yeah, that's the thing. Like, on one hand, I could say, you know, make the desktop, but even the desktop is kind of similar. You know, it's basically, it is an icon view window. it behaves mostly like these here, you know, just that they hide the number of items thing, they hide the scroll bars, and when you say arrange by, instead of going left to right and down, they actually go top right to bottom right and then left. But, you know, these icons behave the same, look the same, so you edit text in them the same. So it might be worth to just say we'll implement them all as the same window, and then at some point I'll go, okay, I'll add an additional window style, you know, where I hide certain elements that I wouldn't want, and then it's a desktop. So I guess a bit same type of windows like my computer in Windows 95. I think that's what I'll start with, yeah. That I'll just start with a window that contains all the volumes. Then you click those, get a window of the same style with all the files and folders in that volume, and then just drill down. And then, you know, you can iterate on that and make it cooler somehow. I've also thought, I think an early draft of Copland, I think that's where I saw it, had, instead of having the icons here in the back on the desktop, it actually had like a light gray bar on the right side of the corner with the icons. I think I saw that in some early screenshot or something. I don't remember anything, so it could also just have been a theme or something someone designed. You know, it could have been not official, but I think that was a thing, and I'm kind of thinking that would be kind of nice to just have a window here that shows the volumes and you know, leave the rest of the desktop empty, so that it kind of feels a little Finder-like, and all the other windows, you know, are basically Finder windows. But that it's still the idea of each of these lists is a window. And also, the desktop is kind of weird in that you don't really see whether it's active or inactive. You only see the other windows. So, I guess you see it because it removes the selection and moves it back to the hard disk. Oh, I guess it moves it back to the hard disk because that's the window I clicked. Okay. So if I click here and then here, it just removes the selection. That's actually, I think that's a System 6 holdover. Now, in System 6, when a window got inactive, it removed its selection. In System 7, when a window gets inactive, it gives you a thin outline for the selection, but the selection is still there. And if you look here, I select the system folder, click over here. Ah, interesting. Okay, it removes them as well. That's weird. I could have sworn that it just keeps the selection in inactive windows in Finder as well, but I guess it doesn't. I mean, you see, if I click Res Edit, it highlights Applications, which is the folder that contains the Res Edit folder. So it always tries to highlight the folder in the other window. Which, makes sense because this is the frontmost window, and if nothing in there is selected, then the frontmost window is selected, which is this object, ResEdit. And that was a strong design decision about the original Finder, was that every item on your file system has exactly one representation. That's this icon with the window that comes out of it. So it's like a file, You have an icon for the file in Finder, and when you double click it, a window opens with the contents. And so that one-to-one relationship, that the window is the folder, kind of is enforced by that folder being selected when the window is selected. But of course, when something in the window is selected, then the folder doesn't get highlighted. But as you see, it gets this kind of empty, open look. Spatial Finder. I guess the Spatial Finder is a bit different. In the Spatial Finder, it's part of it, yeah. But like the main thing about the Spatial Finder is I have this ResEdit window. You see, it's kind of here next to the M button. It overlaps the file title bar and overlaps the hard disk, but the append return value is still visible. I close this window now. I open it again. It opens in the exact same position, in the exact same size. If I make it this size and close it, then reopen it, it reopens at that exact size. And that was, kind of like if you have a desk in front of you and you put a sheet of paper on the left side and put a sheet of yellow paper across it, and then put another sheet of paper on top of that. They will stay in that arrangement. So that means you will always know that that yellow diagonal sheet of paper in between the two seemingly identical sheets of paper is, I don't know, your receipt from your doctors that you still have to pay or something. So like little clues like that, like how large a window is, whether it's more to the left or the right, will help you find your windows again. That is kind of the idea behind the Spatial Finder. And of course, having just one window is kind of a necessity, because if you had two windows for this folder and you open it with no window open, which of the two would you get? So, there has to be that one-to-one relationship. By the way, regarding the discussion yesterday about file iteration, although for the desktop file thing, cat search API is quicker to do full disk iteration, for Finder type folders, the regular indexed get cat info is probably the best bet, mentioning that just in case. Yeah, okay. So, yeah, okay. That's the code I have here already, I think. So if you expand the triangle in front of ResEdit while ResEdit window is open, does it show ResEdit both in the window and the expanded file list? No. The window closes when you open ResEdit in the list view. But I can reopen it and it opens in its position. I'm not sure. I like the thing in macOS 10 that you can have a few files open in list view, but it doesn't steal your other window away. But yeah, it's attention to detail. That if you uncollapse it here, or have it open here, but if you uncollapse it here, it will actually close the window up here. Because otherwise, you know, if I have ResEdit extensions open, now it's highlighted because it's open. If I uncollapse it, at that moment, you know, it would have to highlight both the one in the window and that one here when I click this window. But now, again, it's exactly clear. There's only one icon for this file. It is Node list view, probably. Node classic list view. It's a hierarchical list view. But the detail thing is that that the finder, so the thing where you browse for the files, where you open files in their applications, it has this guarantee that there's only one icon on screen for each actual icon on disk, and only one window for the contents of each icon. Whether that is like here, the contents of a folder in Finder, or whether it's, you know, in this case, the document window in your text editor showing the contents of that file. There's always only one window. Now, of course, there are some text editors which will actually let you open several windows or something, but you know, those don't come from Apple. Blah, blah. Don't come from Apple. Back, I need to check if my pizza dough is ready and prepare the oven. Ooh, sounds good. Now, some people will say, hey, wait, didn't you bring up ResEdit down here? Isn't this, I have ResEdit here, and you have one here. Yeah, but if you look at it, this ResEdit has a little arrow on its icon and italic text. That's not ResEdit. That's an alias for ResEdit. A separate file that just every time you interact with it says, hey, ResEdit is over there. And you can't see me pointing, but yeah, that's what it does. Okay, let's see. We have pb get cat info sync here. So let's try vrefnum dir id dir index. So we need to make this work. So how do we decide to list? I wonder if is there like an invalid fs spec? Because really the first thing we have to do is we have to make it possible to create a window for a file. So fs spec file or folder. All right. File or no, wait. Let's do that here. If file or folder, then m file or folder equals file or folder. And maybe move that over here. All right. So at least now we can create one with a file. And now we just have to detect the null case. So, oh wait, this is of course nonsense because this is the implementation, which can't have default values. Okay, so now I guess for now what we could do is just Boolean list volumes. And then here list volumes false. Else could probably simplify this. But okay. And so now here if list volumes, we'll just build this list like before. Else, and now we have to do the file listing. Let's see. What did that code even do? Okay. File name buffer. We don't need an error string. Okay, we set the file name buffer. And now file or folder vrefnum, and that would be par ID. And I guess we copy the name to the file name buffer. Block move file or folder name. Name buffer. File or folder name 0+1 to include the length byte. All not really exciting. All right. And now call pbgetCatInfoSync. With that cat info. Oh, and we need to do that in a loop. So for int x equals 1, index less than short max plus plus dir index. Okay. So since we overwrote on output, it overrides the name. We need to copy that one from the fspec again. So that way we're describing, and probably with the volume reference number and the parent ID as well. So we need to set all of this up again, then call catalog info to get it rewritten into the info of whatever item is inside our directory. And now file not found error means we're done. If error equals file not found, then break. Breaking out of the loop. And now I'm so glad that I just looked to the left to OBS and saw, oh yeah, I didn't forget to close inside Macintosh again. Okay, if error not no error. Oh, that was already else if. Okay. So if there's an error, then we cancel the whole thing. Skip invisible files. Yeah, I guess that would be a good thing to do. But we don't return no error. Continue instead on our loop. We don't need to do that because we're not generating a text list. Now, is folder. This code is so complicated, and I'm just copying it. And since we're in C++, we don't actually have to do this. We're not using U. All right, much cleaner. So now we know if it's a folder or not. Okay. And now I guess we can access the info. We're not using the folder bit right now, but we will probably be using it. List add row. File name buffer +1, file name buffer 0. All right. That should work. and now let's build. Oh wait, yeah, we need to delete this function first, or rather, let's. Auto scrolling is so fast.
Uh-oh.
Oh, right. Let's just return at this point for now. To do report error somehow. Oh, right, and the K folder bit. That's not 4, that's shifted by 4, right? Because it's the 4th bit. So let's just... should that be right? Okay, so I have this. Now the question is, can I open a folder like this one? Oh, where did my... Oh, I can't. Because... Okay, first let's see if we can make this able to open anything. That's a trick, by the way. If you want an application to be open, to be able to open any file, use a 4 asterisk type, and thereby Finder will know to let you open any file with it. Of course, now I need to quit that. Huh. Okay. Didn't show. Build it again. And now we should be able, once it has updated, yeah. Why doesn't it let me? Oh, I guess 4 asterisks, I think, is all files. What was it? Fold? Come on. Ah, now it works. Oh, of course. We opened an untitled document, but here. Open document, fsspec file or folder. File or folder name. Let's just call this desktop, or maybe okay.
Uh-oh.
Oh, right. I need to put it in the header as well. Virtual. Now let's see if that was the right name. Open document fsspec pointer. Yeah. Okay. And now probably. So, I think we're not getting the app params probably, which I can actually quickly verify. Where is C application? Count app files. Enable debugger, run or debug. C application. Oh. And here. And now started in the debugger. Count is 0. And what is the request? 0 as well. Yeah, my guess is... Oh wait, now I'm launching the debugger. Of course it's 0. I can't actually use the debugger, but I can go printf number of files to open %d count. Okay. And now number of files to open 0. Yeah. So my guess is that the default settings for the project probably say, hey, I'm a modern application, while I want to write an application for where is it? Here. Size flags. It's not high level event aware. Interesting. So the question is the operating system thinking my app is too new? Let's delete it and make sure we create it fresh. But also maybe get rid of some other, let's say suspend resume, can background. Does activate and foreground switch. Let's get front clicks. Let's get rid of all of those, but we are 32-bit compatible. Now